Okay, so our project is for 2D materials defect quantification for MOWSSE type system, quaternary alloy. The dataset was provided by ORNL, and we also used the preliminary codes that were given with it. We made our own codes with batch processing for atom identification. Here is an example of what the images look like, and this is what the code does. It identifies different atoms. Then with this data we classify the atoms into different defects based on the we use difference before that we use the difference of Gaussian method for identification of atoms. Then for defect classification we have 6 different types of defects that we can think of. One is no defect, 1 vacancy, 2 vacancies, 3 vacancies, and interstitial. Everything else is classified as others. We know that the ideal bond length is 183 picometers, so based on that we separate all the atoms into different classes. The classes are then used later in one of our quantifications. In addition to this, we then detect different elements within the atom, within the image, and this is done using the intensity based classification. This is clear in the code named intensity classification here in the GitHub page. And with all of that we then create combined plots which show us how the different elements prefer different types of defects. As we can see in this, that tungsten is not one of the preferred places for the interstitial atoms, but it is one that creates 3 adjacent vacancies. This is in line with the intuition that we have about the material, and this type of analysis takes only about 10 to 20 seconds other than element identification, and with element identification it takes about 2 minutes per image. The idea is that this kind of data set can be used to train machine learning algorithms in future, and because now we had only 19 images, so this is we went for a non-machine learning approach, but we are pretty confident in the data that we are producing here, that if we have thousands of images we could very easily generate the ground truth data that is very close to really the ground truth. But of course it's not 100% accurate, but it does a pretty good job. Thank you.